Hello everyone. In this lecture we will learn about we will discuss about discrete Fourier transform. So before start the discussion about the discrete Fourier transform, we need to first understand what exactly a discrete time Fourier transform and what are the drawbacks of discrete time Fourier transform so that we have come to the discrete Fourier transform. So the drawback in discrete time Fourier transform is that the frequency domain representation of a discrete time signal obtained using DTFT or discrete time Fourier transform will be a continuous function of W, and so it cannot be processed by digital system. Okay, so the discrete Fourier transform has been developed in such a way that to convert a continuous function of W to a discrete function of W, so that frequency analysis of discrete time signal can be performed on a digital system. This is the advantage of discrete Fourier transform. Next is the DFT of a discrete time signal is obtained by sampling the DTFT. Okay, we need to sample the DTFT of the signal at uniform frequency intervals, and the number of samples must be sufficient to avoid aliasing of frequency spectrum. The samples of DTFT are represented as a function of integer k. Okay, and so the DFT is a sequence of complex numbers represented as capital X of k, where k is equal to 0, 1, 2, 3, 4, 5, all values of integer, or you can say all positive integers. Now, since x of k is a sequence consisting complex numbers, this x of k is a sequence consisting of complex numbers, the magnitude and phase of each sample can be computed and listed as magnitude sequence and phase sequence respectively. So let us start the discussion for the discrete Fourier transform. Let us assume x of n is discrete time signal of length capital L. Then x of k, capital X of k, is DFT of x of n. Then the n point DFT of x of n, provided capital N is greater than equal to capital L, can be written as capital X of k is equal to DFT of x of n is equal to summation n is equal to 0 to n minus 1 x of n e to the power minus j 2 pi kn upon capital N, where k is equal to 0, 1, 2, 3, 4 up to n minus 1. So this is the relation for the DFT. Now this x of k is a sequence consisting of n complex numbers for k is equal to 0, 1, 2, 3, 4 up to capital N minus 1, and the DFT of x of n can be expressed as a sequence capital X of k is equal to capital X of 0, capital X of 1, capital X of 2 up to capital X of n minus 1, where the time domain sequence x of n is small x of 0, small x of 1, small x of 2 up to small x of n minus 1. So for n point sequence, the DFT will be having n number of frequency terms. Now if a discrete time sequence x of n is given, then we can calculate x of k, which is the frequency representation of the discrete time signal x of n. In the same way, we can calculate x of n if x of k is given, which is called IDFT or inverse discrete Fourier transform. So IDFT can be calculated as x of n is equal to DFT inverse of capital X of k is equal to 1 upon capital N summation k is equal to 0 to n minus 1 capital X of k e to the power plus j 2 pi k n upon capital N, where n is equal to 0, 1, 2, 3 up to n minus 1. And we can say the sequence which is obtained x of n has n number of points, x of 0, x of 1, x of 2 up to x of capital N minus 1. So for capital N point x of k, we can calculate the IDFT, and which is x of n. Now let us write down the equation for DFT and IDFT in terms of Twiddle factor. So as we know, x of k, DFT equation x of k is equal to summation n is equal to 0 to n minus 1 x of n e to the power minus j 2 pi k n upon capital N. It can be written as x of k is equal to summation n is equal to 0 to n minus 1 x of n w subscript n to the power k n, where w subscript n is equal to e to the power minus j 2 pi upon capital N, and is known as Twiddle factor, and is known as Twiddle factor. In the same way, for IDFT, x of n is equal to DFT inverse capital X of k is equal to 1 upon capital N summation k is equal to 0 to n minus 1 x of k e to the power plus j 2 pi k n upon capital N can be written as 1 upon capital N summation k is equal to 0 to n minus 1 x of k wn to the power minus kn, where again we can say wn is equal to e to the power minus j 2 pi by capital N. Is called the Twiddle factor. In this way we got the 4 equations, 2 for the DFT and 2 for the IDFT.